Funding for this program is made possible by the Corporation for Public Broadcasting, Louis B. and Louise Hirschfeld Coleman, Sue and Edgar Wackenheim III, and contributions to participating stations. Coming up, an innovative wheelchair system developed by college students.
I was drawn to it because it was the only senior design project that directly helped somebody. What we were making was for somebody.
And technology to mitigate sports injuries.
Back in the old days, if you took a concussion, your coach tended to tell you to just shake it off. If you were able to skate, then you were back on the ice.
Exploring the frontiers of science. Probing cutting-edge technologies. Seeking answers to the big questions. Welcome to SciTech Central. Albert Manero develops technologies that help people. Recently, he and several University of Central Florida undergrads created a low-cost device that makes it easier for quadriplegics to get around.
One of the challenges with disability technology is that it's difficult to make enough money commercially to have a lucrative business. And universities and nonprofits are uniquely positioned to be able to take some of that risk financially and be able to have a huge impact.
There's not a big population of people with spinal cord injuries, especially at a high level. Like, I'm a C3 complete, so I'm pretty high up in the cervical area. So there's not the funding, there's not the money out there to really bring a lot of change to treatments and research and things like that. So anything I can do to help get the word out that we need this type of help, assistance, innovation, whatever you want to call it, that's why I'm involved with this.
Charles Merritt relies on his wheelchair for countless everyday tasks that most of us don't even think about. Albert Manero had an idea for a low-cost invention that would make it easier for quadriplegics to get around. At the University of Central Florida, engineering students must complete a senior design project in which they create a useful device. Albert took his idea to several undergrads.
I was drawn to it because it was the only senior design project that directly helped somebody. What we were making was for somebody.
I think that's one of the strengths of our team, is that we can take technology and see our work and then find the bigger purpose for it. And when you infuse that with compassion, you end up really being able to engineer hope for a lot of people.
To help is a great thing, and I think a lot of that's sometimes lost when you get an injury like this because you just feel like there's no hope. But it's good to know that there's people out there like Limitless Solutions that's doing things to help you.
The wheelchair control system uses electromyography, EMG for short, a technology that detects muscle activity.
When you flex any muscle, you generate a voltage like a battery. We can read that, and we can do the signals processing to be able to use your flexing of muscles in a pattern to be able to control the wheelchair left, right, forward, and back.
The team is using Arduino microcontrollers, an open source product.
This Arduino acquires the voltage signals from the EMG sensors, and the program on this Arduino takes the numbers and plots them in a more graphical sense.
The designers use the graph to determine threshold values for a specific wheelchair user. Those values then allow them to program the wheelchair.
To set the thresholds, we look at the baseline readings, which is what we call like noise or just normal everyday activity. You want the threshold value, which is the value that the microcontroller, when it gets the signal from the EMG and it's above this threshold value, it tells the wheelchair to go in whatever direction that is programmed to go. And if it's below this value, it does nothing. So now I'm ready to demonstrate the wheelchair. If I clench the right side of my jaw, I go right. And if I clench the left side, I go left. And then to go forward, I quickly clench both, and then I stop.
Basically, it's just as easy as biting down or chewing. So it kind of comes naturally once you get the hang of it.
Watching Charlie drive out of the lab with it was one of the most exciting points of our work here. It's incredible to be able to see the technology actually help someone.
Oh, I was so happy to see somebody that had never seen our device, didn't know how it worked, and then within 5 minutes of us telling them how it worked, he was able to ride around and go all through the engineering atrium. It was awesome.
It doesn't obstruct your everyday activities. So for people to be able to become involved with it, to get it attached to their wheelchairs, it's really simple.
And we've gotten Charlie's feedback, and we're working now to make it even better in the hopes of getting this into the different wheelchairs for people with ALS or MS or traumatic brain injury or quadriplegic victims, and being able to empower them and give them back their freedom and independence so they don't need an attendant to drive them around, but let them go and roll out through life.
what they've come up with just brings it to the masses and allows people to maybe get outside. It allows people to kind of get around without having to have somebody drive their chair for them. So the expense of it is next to nothing.
Limitless Solutions, the nonprofit founded by Albert Manero, is creating inexpensive, innovative devices that help people. One of the group's biggest successes so far are prosthetic arms that have made an impact internationally.
So I'm here with Albert Manero from Limitless Solutions. Albert, just tell me a little bit about the bionic technology that you've developed.
Yeah, so as a team of UCF students here, we've put together this company, this nonprofit called Limitless Solutions, and we develop these 3D printed bionic arms with custom electronics.
So how have you done that? Just, if you can, in sort of layman's terms, just describe a little bit about that technology.
So the advent of 3D printing and additive manufacturing has helped us lower costs immensely, because instead of working with a machinist and working with metallics, you can make incredibly complex shapes strictly out of Lego plastic.
So tell me about Alex. This was a little guy that was really into Iron Man and wanted a particular design for his bionic arm.
So Alex was our first child we worked with, and he came in and he really wanted it to be expressive. And so when we talked with another bionics expert, Mr. Tony Stark, he was very excited to be a part of it, and he made Alex's day when he delivered what was an Iron Man arm.
And in terms of this field that you've got into, what drove you to, what was your interest in that initially?
I was really inspired by one of our professors, Dr. Alain Kassab, and his ability to transition from working with jet engine technology back down to bones and all the biomechanics, or even with the heart. It was really inspiring that you can use your engineering to not only invent great things, but to really be able to help people as well.
And what further applications down the road do you think you might see this being, adaptable to?
We certainly see this as the first steps towards making disability options available for people all over the world. And as our emails continue to be filled with people from all over the globe asking for support, our goal is in the next few years to be able to really help on a global humanitarian level.
Albert Manero, thank you so much for joining us.
Thank you for your time.
3D printing is a technology with a lot of buzz. The printers are already used for prototyping, and experts predict they'll soon revolutionize manufacturing. A number of companies recently gathered in New York to unveil new printers, new scanners, and new possibilities.
The Inside 3D Printing Conference and Design Expo boasts 12,000 attendees, 88 companies, and one car.
1983 Camaro, and I completely encapsulated in 3D printing shapes and different technologies, 3D printing related.
The 3D car's designer incorporates 3D printing into his artwork. He says it gives him a new way to create.
Right now, it's for the first time in history when you can create an object in a virtual world and bring it to reality through 3D printing. You create something out of the thin air and becomes a touchable, real object. So these are exciting times.
3D printing gives creators the power to make just about anything, on the spot, without a factory, vendor, or parts. Jonathan Jaglom is the CEO of MakerBot, a global leader in the industry.
The way we pitch it is that individual is the creator. Now the creator can mean a whole lot of things. It can be a tinker maker, it could be a designer, an engineer, it could be a student, it could be a teacher wanting to teach and use this equipment for teaching. So that creator is really at the crux of all those different directions. And we as MakerBot, our role is to facilitate that creator.
3D printing, also called additive manufacturing, was developed in the 1980s. Like a paper printer, digital files are created in design software and sent to the printer, where the item is created layer by layer. At first, manufacturers use the technology mainly for prototyping.
The designers, the engineers, the tinkers, the makers literally have the printers right on their desk, and they can print something out, take it out, assess it, evaluate it, and optimize the product before going into production.
3D printing has mushroomed in manufacturing, education, and the consumer space. A 2014 report by 3D printing consulting firm Wohlers Associates forecasts the industry's annual revenue will multiply from about $3 billion in 2013 to more than $21 billion by the year 2020.
It's going to have a huge use on the consumer side, but the real money that's going to be made will come from totally revolutionizing manufacturing as we know it.
Consumers can print from a growing online library of digital designs. Lucas Matheson is the CEO and co-founder of PinShape, a marketplace for these designs.
Everything from toys and games and a lot of products that are focused on kids to products that are around the house and actual products that are used to fix things.
Companies and designers set a price for users to access a file, which can be sent directly to their 3D printer. But the designs can be tweaked and customized, bringing concerns about intellectual property.
What's going to happen is everyone's going to have a scanner in their pocket, in their cell phone. People are going to be scanning millions of models and uploading them online. And we're going to need to really think about how that intellectual property is managed and how we're able to identify models and designs that are uploaded to the web and whose property is it and what can we do with it.
A growing market of scanners also means virtually any object can be scanned and replicated. Some scanners are small enough to attach to your iPad, while others are made for larger objects. Artec's Shapeify booth does a full body scan in just 12 seconds and generates a ready-to-print file in 15 minutes.
In a few hours, you can have a mini-me, or a Shapey as the company calls them, like mine, with enough detail to see the wrinkles in your clothes and the flush in your cheeks.
We'll see such booths as ours in shopping malls, in Disneylands. Right now we can see photo booths there where you can get your photograph. And in the nearest future, full body scanners will be there.
Experts predict that in the coming years, we'll see lightweight 3D printed parts for cars and aircrafts, more options for affordable prosthetics, and even 3D printed organs for transplants.
I would say almost every part of your body will be 3D printed if you need a replacement. It's nothing short of spectacular. So there's really nothing that 3D printing won't touch.
One in 5 Americans currently own a piece of wearable technology. So, who's buying these trendy devices? And how are they being used?
We've all heard the advice. In order to stay fit, there are certain steps you have to take. Some would say a certain number of steps.
My daily target is 10,000 steps.
My goal right now is to get 100,000 steps.
2,298 steps since I've woken up.
The benefits of regular exercise, along with a balanced diet, are well documented.
But can walking really impact your overall health? And will massive amounts of data motivate you to stick with it?
These are the questions driving the new craze in wearable fitness technology. They're called activity trackers.
The major goal of a wearable is to start a behavior change. Number 1, to form habits. Number 2, socialization. And the last thing is to show somebody progress.
Do you know what this is?
I do know. That's a Fitbit. I've seen other people wearing them around.
Don't know what that is.
I've seen in the shop some of them.
Though Fitbit may currently be the name to beat in wearables, the competition is fierce.
For the Fitbit series, we have the Flex, we have the Charge heart rate monitor, Charge HR, and the Surge. That sounds like power right there. And then there's also the Up 24, which started with the sleep tracker, all time of day, and the Up 3, which has the heart rate monitor. For the Polars, it's the M400 series, that's their top of the line model, and for the Garmin's, it's Forerunner. It started this whole trend.
Some of them look like a simple rubber wristband, but the hidden sensors track all sorts of things, like activity level, heart rate, and sleep quality. But the most common uses...
Well, there's actually 2 that most people are interested in. That's calories and steps. If I want to lose weight, I can see what I need to do and how easy it could be just to meet those goals.
Movement is key for Jennifer Fisher, a self-proclaimed Fitbit fanatic.
I've always kind of been really into health and fitness, and I've also been really kind of into technology, so I went and I bought my first Fitbit Flex. You know, that was kind of all she wrote. I spend most of my day on the computer, you know, doing work, answering emails. One of the things that I've started doing actually with my team is we all have Fitbits. We'll all put our headsets on with our cell phones and we'll go for a walking meeting. I measure, you know, the steps that I take. It shows my resting heart rate right now. Mine vibrates every 2 hours as a reminder to me, you know, to go move around a little bit.
I'm an attorney and a spin class addict.
For Larry Silverman, it's not about the amount of movement, but more about controlling the movement.
You know, this is my unfair advantage in spin class. Right now it's at 72 for the heart rate, but that'll go up. Normally I'm looking at my watch to see what my calorie burn is. 874 calories, 176 max, and that's become very addictive.
So is it me, or does it seem like you have to be fit before you even buy your Fitbit?
People who go to the gym every day, and they're always up for the newest devices.
What's the deal? Do you really need one of these if you already have the beach body?
A meta-analysis of all the studies done to look at weight loss with a fitness tracker showed that you lose approximately 0.05 kilograms per week.
But for church pastor Matt Mashburn, it was just the first step on his journey to major weight loss.
I've lost a net of 85 pounds.
He's used his Fitbit religiously for the past few years.
I went to the doctor, got some bad news. I had type 2 diabetes and high cholesterol. I decided that day I was going to make a change, and it looked like an interesting way to kind of turn weight loss into a game. There's a social aspect to it where you have friends and it'll sometimes cheer you on. It'll say, hey, you just passed Tony or you just passed Vince. I've had 17 million steps since I got it total. And I've done a total of 8,200 miles since I got it.
Water trackers, salt, sugar, fat burned as well, and calories burned during periods of intense exercise.
I can track my weight, I can track my food, I can track my activity, I can track my sleep.
When you have hundreds of thousands of people and you put all this data together, you get something that we call big data. So the question is any of this data meaningful? None of these apps have independent evaluations. They are not regulated.
So what's to become of these wearable personal trainers? Will they die the same death as jazzercise classes or the old food pyramid? Or will they actually have some staying power?
I definitely think there is a huge future in wearable technology, but we have invented the technology, but we haven't actually studied the implications of the wearable devices.
With all kinds of wearables, your friends can announce that they hit 10,000 steps at 2:54 p.m. today, and you can tell them all about how you burned 683 calories on your 11.5-kilometer run. And in a few years, you might have another set of stats to add to that list, a set that's a little more personal. Engineers from the University of California, Berkeley unveiled the first wearable device that can quickly and accurately measure the qualities of sweat in a ton of detail. In other words, it tells you what you're sweating out while you're working out.
Companies are now manufacturing devices that seek to mitigate health risks associated with sports. But do these mass-market gadgets promise more than they can deliver?
I've been concussed 5 or 6 times that are memorable. So the most serious one was a complete blackout. I mean, I woke up on the bench and I didn't really remember much about the hit, just woke up on the bench and had a really bad headache for, I'd say, about a week afterwards. Back in the old days, if you took a concussion, your coach tended to tell you to just shake it off and get back out there. If you were able to skate, then you were back on the ice.
I also started playing ice hockey in the late 70s and early 80s, and I can't recall much discussion of head injuries either. But in the years since I strapped on my first skates, many coaches in many contact sports have changed how they deal with concussion. From hockey to American football and rugby, public awareness has grown of how such incidents can have long-term health consequences. And some companies are working to develop technologies to help deal with those risks, particularly for kids who play the sports. The Reebok Check Lite is one such effort. Reebok says that the device doesn't diagnose concussion, but is an impact indicator and pitches it as an extra tool to help coaches identify when a blow to the head could be dangerous.
The way the device works is it has a number of lights, and the color of the light indicates the severity of the impact. Amber means more or less a moderate hit, but red suggests that it's the kind of impact that could lead to a concussion. I'm going to test it out by just hitting on my hand to see what happens. Red. So that's a severe impact, and the idea being this is an indication to coaches, trainers, parents that maybe the player needs to be checked out.
It's not just in contact sports that new takes on old devices are trying to help minimize risk in sport. London-based startup Blaze is bringing ingenuity to urban cycling. Co-founder Emily Brooke turned her university project into the Laser Light, a bike light that uses a laser to project the symbol of a bicycle 6 meters in front of the rider.
I wanted to find the biggest challenge for city cyclists, whatever it was, and tackle it. I didn't care if it was getting wet or your bike nicked or getting lost, but it had to be the biggest problem. And straight away, speaking to cyclists, personal safety. Personal safety was the biggest barrier. 79% of bikes that are hit are traveling straight ahead and somebody else turns into them. It has a normal light, it has a white LED, but then it also has a green laser. We use laser because laser is very good for projection. So we use these brand new technology called direct diodes, which is actually developed for pico projectors in mobile phones. But it really is a kind of cutting edge of laser diode technology.
While Reebok and Blaze are clear about what their technology can and can't do, some worry that many products don't match the marketing hype behind them.
It's probably a bit oversold. And it's great for some of the instant feedback in terms of looking at your split time when you run, or looking at a GPS map of the distance that you've covered, potentially even your heart rate. But actually, do real weekend warriors know what their heart rate really means, or that it's really going to change their performance? They don't have a sports scientist analysing them and helping them and telling them. And ultimately, consumers need instant gratification.
Dr. De Medici says that the really big step will be in data. As we get better at analysing the reams of information being collected by all these sensors and apps, it will become increasingly possible to use technology to manage safety in sport.
These health and fitness apps, the ones that are probably useful are the ones that tell you what to do. So if you want to look at a particular exercise or a particular way of training. And a lot of the other thing, I think, is still a lot of hype, but potentially, I think really where the big changes may come is once we start to gather a lot more of this data. The value is in the data. If we can if more people can start to feed in their data and we can analyse that, then we can start to give people more information about how to use the data they collect and how that data can influence their training or their performance.
The only surefire way to get rid of every health hazard in sport is to either change behavior or change the rules of the game. Until that happens, new technologies are emerging that at least help us to identify and mitigate against some of the risks. And while it will be dangerous to think that any device will prevent us from ever getting injured, it won't hurt to look at new innovations coming down the line.
That's all for this week on SciTech Central. Thanks for watching. Join us next week for more stories from the frontiers of science and technology. Funding for this program is made possible by the Corporation for Public Broadcasting, Louis B. and Louise Hirschfeld Coleman, Sue and Edgar Wackenheim III, and contributions to participating stations.